We are going to talk about proof of reserve. My name is Hubert Rachwalski. I'm representing vlayer. Vlayer stands for verifiable layer. I will introduce us more in a second. But most importantly, I'm not alone here today with Phillip from Swarm.
Very nice to be here. Thanks. Go ahead.
So very briefly, what verifiable layer that we are building is all about. We are on the mission to build a stripe of verifiable data. We really are inspired by the best possible developer experience. We do believe that our crazy changing world that relies more and more on automated and semi-automated processes for making decisions for us, we all know and experience the AI happening, will need a structural way of injecting more verifiability when it comes to the data inputs. And the layer is supposed to be this holistic layer which takes into consideration all possible, down the road, all possible verifiable data sources that are already generated and processed within the economy. And we also want to make sure that the business model that we are, at the end of the day, are going to propose is aligned with the goals of the builders, because we are building infrastructure and a set of developer tools, but at the end of the day, we need developers to adopt them and make sure that their apps are reinforced by this verifiability and additional data in their apps. That's the very short intro.
So let me put this a little bit into context, and I know that I talked a little bit about what Swarm does, but very shortly, we are basically sort of a tokenization engine and a secondary marketplace for RWAs. We have two businesses. One is actually RWA tokenization, where we do all sorts of different things on tokenizing public stocks, tokenizing gold, but also then we have the RWA trading suite alongside with it, which means there's specifically something that I want to point you to called DOTC, which you can see actually on swarm.com, which is basically a peer-to-peer trading platform to actually trade RWAs. Now, proof of reserves in the context, and this is a lot going on the slide, but I'll talk about two things on this slide, right? So this is how our gold works, which basically says that in order to become sort of not a security, not an asset reference token, not something that really has to be in a regulated environment, we took the position to say, let's build true ownership of a gold bar on chain, which means that the certificate of the gold bar that is sitting with our partner Brinks is embedded into the NFT, and all sorts of different ownership rights are embedded into that NFT. So you can move it around, you can actually instruct us which vault of Brinks it's stored in. You can actually say, I want to redeem this, and it will physically be delivered to your door, right? So this is as good as a ownership of a non-physical gold bar can get, right? Now, the next level up is then that we then say, okay, well, here's a smart contract way to fractionalize that. And then you go into the fractional version that then goes into the blockchain world to do all sorts of DeFi applications. We actually launched gold lending with a partner recently. But the neural point that I want to point to is actually here, you have to trust that something is sitting within Brinks. Something with that number is sitting within Brinks. And this is the dirty little secret of RWAs, that there is somewhere that moment of trust where you have to trust an organization or trust a issuer that something is really happening, right? Now, our goal in collaborating was to reduce that trust to the least extent. So it's really, really not dependent on me as a person, my company, or even for that matter, like, us being way smaller than a Brinks is, for example, in this case. So what I'm going to do is actually walk you through how we think about this and what role vLayer played in this. So the typical, and maybe one sentence why unambiguous transparency is so important, because the confidence in these assets starts and ends with knowing what you're actually buying. If you don't, you're just trading air. It could be something one moment, it could be something, another thing the next moment. You really don't know what this is about. So the way that typically sort of certain Oracle providers or certain issuers have thought about this is, okay, there's a certain amount that is off-chain, let's say it's gold in the Brinks vault, and then there's on-chain a certain supply. And that has to match up, right? Now, the easy way was to say, okay, well, there's some records paper records that have come off chain from someone, and we hand them over to an auditor, and then basically, ideally, that matches up with what is on chain. And this is, by the way that Circle has been operating for the past 10 years, right? Where it's basically saying, okay, well, one moment there's a certain amount of cash and treasury bills in the account, and here's the amount of USDC. Well, that matches up. The problem here is that, number one, that auditor costs a lot of money. Number two, that auditor does, a snapshot at a certain point in time, so it could match up, but the next day, that money could be somewhere else. It's not clear that it's going to be there continuously. And the auditor capabilities are pretty low. Not every auditor on the planet is willing to look at a smart contract, understand what a smart contract is, and actually be able to operate what's associated with it. So what we built in contrast to that is two things. One is we have, with vLayer, we built a verified supply attestation. And Hubert will walk you through actually the exact technology that they're using, but the effect is that Brinks, or a brokerage system in our case, has a technical interface coming from a certain source, saying a certain thing, and then vLayer basically proofs the source, proofs what's happened, and puts that as a verifiable proof on chain. And we will allow people to ping that proof to reproof whenever that's necessary. So you have a continuous way to say, is really in that repository, is something there or is it not there? The second thing that it then merges with is what we call attested data. So if I'm an issuer, I can say certain things about my asset. And usually I put that on a website. On the website, things are there for the time being. They could be gone the very next moment. So I don't have real full clarity what happened, when I bought the asset, what was really said. So that snapshot of information that goes alongside with the asset on a timeline is super critical. So what we now have built is something where the issuer can actually manage their prospectus, their information, their contacts, their videos describing the asset, whatever the proofs are, and it sits in a Git book, and that Git book then actually puts everything on on what we've built called ChainWiki, which is basically just an online version, a sort of decentralized stored version of a wiki. So I have a timeline where I can always go back at a certain point, say what has been said about the asset. And yes, there's a third layer that still someone as an auditor can come and say, is this all true or not? But at least we have the least amount of sort of trust, because we're actually borrowing the trust from the institutions that we're working with, either that's a custodian or a vaulting company, and we're saying, okay, what responsibility am I taking over as an issuer in having said a certain thing at a certain point in time? So if I one day decide to change the terms, well, it only is for the time forward, because backward, actually the old terms apply. Hubert.
Thanks. So hopefully you're still with us. So maybe just a few boxes to explain the exact flow and how we are transporting the trust in this exact example from Brinks, one of the largest vault management companies in the world, all the way to a smart contract that is visible to any individual investor buying tokenized gold with Swarm. So effectively, in an ideal world, Brinks would be a technology company that would be able to communicate with blockchain or in any encrypted way directly with where we want them to. But the reality is that they are in the business of managing vaults. They are the best at managing vaults. They are not the best at adopting some of the software solutions out there.
And they have shitty interfaces.
I wouldn't say, I'm in no position to comment on this, but the reality is that Brinks, as so many other companies with a massive scale that could be relevant for RWA market, are simply not there and will not be there probably for the upcoming few years. So what we can do to still make it work? The reality is that Brinks is okay with sending emails. So their mailing server is able to send a structured content on a recurring basis. And that's exactly what we are intercepting with vLayer. One of our products is called email proofs, We are using zero-knowledge proofs as an underlying technology, but none of that matters because none of you, as people interested in our RWA tokenization, need to understand how the mathematics underneath it really works. What really matters is that there is an email coming directly from Brinks. We are not forwarding any message. There is a signature of the mailing server of Brinks that is sending an information that this is the list of gold bars stored in particular locations and a bunch of other attributes that we are effectively parsing and generating a zero-knowledge proof of the correctness of this data, and then we are able to transport it directly to the smart contracts that Phillip was referring to. So as you see, there are a bunch of flows and some more technical names. At the end of the day, the uniqueness of Swarm offering is that whenever you are purchasing an amount of tokenized gold, you have this kind of link with know your asset object that it lives on chain, so you can always access this information. We are simply the conveyor belt of the trust from Brinks, and using the encryption and a cryptography that zero-knowledge proof is introducing, we are able to transport this trust directly to this object. So at the end of the day, this is obviously a very fancy term about asset token fusion, but it transmits a very simple message. We want to make sure that whatever is tokenized has a real and continuously verifiable representation in physical world, and that's exactly the purpose that we are after with our technology. During this presentation, we were talking about email proofs, which is one source of data, but as mentioned, stripe of verifiable data. We are after other sources, especially web sources. So think about any centralized application. You have number of apps on your phone with you today, and there's a lot of private data that could be relevant for various flows that happen on chain. With web proofs, you can enable a flow in which this data is being transmitted to your smart contracts. And we also do have two functions that work for historical state of the blockchain, so effectively accessing historical data that is on one of the networks out there. At the end of the day, these are functions. Think about them as building blocks that you or your smart contract developers can simply use without learning all the mathematics and just can trust the data that is needed to make your business flourish and give more trust to your customers. A few words about us. We are backed by A16Z Crypto, CSX, and we've been on our mission for relatively short because we are in the business for more than a year. But a team of 25, we have released our testnet. So actually the tools we are talking about are available to all of you to check out. Go to our website. You can access the documentation and the API keys. We have over 20,000 developers right now playing with this. We do believe that it's going to really move the needle when it comes to bringing more data, especially from Web 2 to Web 3 businesses. And by doing so, we should help us grow. Like that's at the end of the day what this event is all about. We have a booth, so feel free to swing by and chat more about this. Phillip, thanks again for your trust. We are transporting trust for you, and obviously spending time with.
We're making it trustless, right? Okay, got it.
Exactly. Thanks a lot.